So now let's think about the same change and the same comparison between liquid water and gaseous water, but now look at the entropy, not the enthalpy. So which has a higher entropy? The liquid, the gas, they're exactly the same, or it depends on the temperature. So now if you remember anything about entropy of substances, you know that it's got to be the gaseous water that has higher entropy. And that's because gases have higher entropy than liquids, have higher entropy than solids. So a very quick review of entropy. Okay, technically here again, entropy depends on the number of equivalent microstates of a system. That is the number of equivalent ways we can make the same system, distributing the molecules, distributing the energy. It's very easy to deal with this qualitatively right now. We want to remember sort of the things that change entropy, and in particular the sign for the entropy. So if I increase the volume of a substance, I will increase the entropy. If I increase the temperature of the substance, I will increase the entropy. If I have a larger number of molecules after a process, this will increase the entropy. And last but not least, phase changes, going from a solid to a liquid to a gas, will increase the entropy. And again, this has to do with these numbers of microstates. Changing the volume, there's more ways to arrange the molecules, more microstates, more entropy. Increasing the temperature, there's more energy to distribute, more energy, more microstates, more entropy. Increasing the number of molecules, more microstates, more energy. And again, solids have a very fixed configuration. The molecules are all in a fixed place. Liquids, they're confined, they're next to each other, but they're moving, and so we have fewer ways to represent them, or more ways to represent them, so more microstates. And then the gas is the biggest of all. The gas, the molecules are willy-nilly all over the room, many, many, many possible microstates, much higher entropy. And again, remember, the universe is always tending towards higher entropy. This was the second law. Getting back to our phase transition, though, what does this matter for us? The thing to keep in mind is that gases have higher entropies than liquids. And in particular, almost all substances, when going from a liquid to a gas, the entropy change is very similar. And that's because the difference has more to do with going from a liquid to a gas than it does on the particulars of a compound. And thus the phase change itself, there's a fixed change in entropy, and it's almost the same for every substance.